Do you run a CNC router in a small workshop and your metal chips are all over the place? Or worse, your woodworking router covers your shop with layers of dust? Then all you need is a proper dust-proof enclosure, and I'll show you how it's done. Hello and welcome to my channel. I have finished my new DIY CNC router lately, but before I can use it, I have to build an enclosure around it first. I will use this machine predominantly for woodworking, and although there will be some kind of dust collection added later on, this will never catch all the dust. And that's why I built a dust-proof enclosure with air filtration on top. In case you haven't seen the videos about the router build itself, I have added the playlist in the description below. My router sits in a corner, which makes the build of the enclosure quite easy because I have already two sides covered. I start with the front left side, where I place the monitor and the touch panel. Because of the corner layout, this is a dead space anyway and ideal for placing these components. Behind this part of the enclosure are the different control cabinets, and with the monitor integrated, I save further space on the bench and the adjacent wall, where I'm going to store my tool holders for this machine. I always build my enclosures with ETEM-compatible extruded aluminum profiles with 6mm slot size. They come in 60x60, 60x30 and 30x30 size, and that makes it very convenient to combine them in such a build. And with the 6mm slot, you can easily slide plexi panels, HPL boards or other stuff, which makes them very versatile and fast to build with. I milled the cutouts for the monitor, touch panel and the air intake for the control cabinets into an HPL board. Placing the cabinets inside of the enclosure is not ideal, but in my overall setup, the only possibility. Important is that the air intake for the ventilation of the cabinets is on the outside and not inside of the dusty cabin. On top of this section is another small HPL board with the two main switches that cut off the 230 volt and 400 volt power from the CNC controller and the VFD. As you can see, I'm reusing some cutoffs from my previous enclosure because these profiles have many benefits as mentioned, but they are pricey as well. A better planning on my part where to place the fixation bolts would have been nice though. Oh, and by the way, I have to apologize for the poor video quality, but my camera struggles here a little bit with the constant change between my dark shirt and the bright white HPL board. I marked out the 100x100mm VESA fixation holes of the monitor in another HPL board and drilled them by hand, following the good old rule measure twice, drill once. The board is placed then in the rear slot of the profiles, which spaced is 30mm behind the front board, and that is ideal with the EEG Touch monitor. After this section is completed, I started to build the right side of the enclosure, which has a large sliding door in front to access the router and a side window on the right, which can be removed for cleaning. I first bolt a 60x30 profile to the wall and then add all the remaining profiles of the frame. To connect the profiles, I use a mix of hidden connectors, which are screwed directly into the slot, and regular angle connectors. The sliding door is great to have a large access to the router and still have access to the monitor and touch panel on the left, but it requires as well a lot of space to the right side. This is the reason why I cannot open the full length and I need to have a small fixed window on the far right. But it still opens 1100mm, which is more than enough. And finally, the last profile on top is bolted in place, which completes the fixed frame of the enclosure. The frame of the sliding door is bolted together directly without any additional connectors. For this, I have to tap a few M6 threads in the sides first. I use a power drill and lots of cutting paste for that. This paste is perfect for tapping because it adheres to the tap really well in contrast to a cutting fluid. If you're interested, I have a link in the description below. In the mating profiles, I had to drill M6 countersunk holes through the entire 60mm width of the profile, 3 on each end, and I prefer to do this on the mill rather than by hand. But the profiles are longer than the work area of my mill, so I had to be a little bit creative here and do this with an open door. For this kind of sketchy stuff, the modular vices are perfect. The design is from John Saunders from SMW, and I can highly recommend them. I made my own ones some time ago out of stainless steel, mainly because I needed them to match a metric 50x50 M8 grid pattern, which he doesn't have. In addition, mine are 5-inch wide instead of 4. I use them a lot to clamp irregular workpieces or things that need to go in a 90-degree angle on the fixture plate, like this stuff here. The sliding door works with regular heavy-duty drawer slides. I first have to mark, drill and tap the M5 threads into the extrusions, and then the slides are fixed, one part to the frame and one to the door. The door frame is made out of slot 5 60 by 20 mm profiles. It is mounted as an open C and the 5 mm plexi window goes into the profiles. After that, the frame is closed and the door is finished. To protect the bottom drawer slide from chips and dust, I have added a lamellar seal made out of two L-shaped aluminum profiles that slide with a 1 mm gap above each other, one fixed to the door and one to the frame. The 20mm thick drawer slides create a 20mm gap between the door and the frame, and this is closed from the inside with a 3mm thick rubber strip on the frame and from the outside with a flat aluminum plate on the door. The last thing to make was the removable side window. This is made out of some leftover 30x30 slot 6 profiles, which I had to cut to length first. Here the profiles are connected with 30mm cube connectors. Same principle, a C-frame first, then the 6mm plexi window, and then the last profile to close the frame. This window rests on the 4 angle connectors of the frame and is held just in place by a press fit. And this is the enclosure so far. As you can see, it is still open on the top, and this is where an air filtration system will go, which I will cover in one of the next videos. What is also still missing is the touch panel for the aiding CNC control software, which I will show in the next video. If you like this video, give it a thumbs up, subscribe to the channel and hit the notification bell. Stay tuned and see you next.